Hi, everyone. Welcome to the longest session title that you'll probably see at Google Cloud Next. We tried to see how far we could wrap around, but really, this is a much shorter title. MultiCluster Management, the GK on-prem. We had to keep it a little bit hidden until the day one announcements. But now that we've talked about GK on-prem, we're going to do a little deep dive today, show you guys what we have, and give you some more information on what we've built out. So quick intros. My name is Weston Hutchins, product manager on the GKE team.
I'm Delio. I'm a product manager on the GKE team as well.
And I'm Nikhil, software engineer on GKE team.
Okay, so I've got a little story to tell. I'm going to sit down. We started this demo by wheeling our entire rack from backstage out here, and we're debugging some issues. We ran into a little snafu where we couldn't get an IP address for the rack. So we're going to wait on the demo. We moved it all the way backstage again, and Nikhil is actively debugging. I hope to be able to show a demo for this. We'll try to come back to it later. But right now, we're just going to jump into slides. Nobody said on-prem was easy. Clearly, we're learning that up on stage here. So I'm going to start by giving a little background on our journey to cloud services platform. A little history lesson here is about, we started with mainframes, we started with big boxes, and every evolution since then has been trying to move further and further up the stack. So along came virtual machines which abstracted away the hardware and allowed you to spin up multiple machines on the same host. And then containers came into popularity. Now, containers have actually been around for quite some time. Google has been working with containers for over 15 years, but we didn't really start to see widespread adoption until Docker. Around 2013, when Docker unveiled their stack for a lightweight container runtime with great packaging, portability, and deployment semantics around these environments where you could really package up your application and its dependencies and move it from host to host. That's where we started to see containers actually becoming a reality. But of course, Docker solved the problem of taking an app and its dependencies and deploying it onto a single host. That was never going to be the end journey. We always needed something a little bit more. And this was around the time that the team started to think about Kubernetes. So how do you take not just a single container on a single host, how do you take multiple containers across multiple hosts and orchestrate that over a fleet of virtual machines? So Google started to take all of the lessons we've learned from our internal container management system, Borg, externalize those with Kubernetes. But as Urs said in the day one keynote, Kubernetes was also never the end state. It really is that consistency layer between infrastructure and then higher level services. It allows the operators to think about what's provisioned underneath and allows the developers to just worry about having consistent tooling between the two. And a lot of the announcements that you guys have seen at GCP Cloud Next have been focused on these higher level services. So we talked about Knative in the keynote this morning, which offers serverless and some PaaS level functionality that can run on top of Kubernetes. We announced Istio 1.0 GA, which is the service mesh capabilities to actually think not just about Kubernetes deployments, but how services connect and talk to each other, along with how you can control connections between those with security and everything else. And then there's not tools that just Google has, but like the community has built in the open source as well. So we have CI/CD tools. We have monitoring and logging agents like Prometheus. We have things like the Open Service Broker, where we actually can connect to services running in cloud using an open API. And our customers came to us and they said, well, we want you guys, we love these open source technologies, but we want you guys to manage it for us. And this is where we started offering hosted versions of all of these solutions. So Kubernetes became Google Kubernetes Engine, our hosted managed offering. We run that on top of our infrastructure stack. And a lot of the announcements today came out for like serverless for GKE and Istio for GKE. These are managed offerings that we want to install inside your Kubernetes cluster so that you can think about the important thing, which is application development and not having to manage infrastructure. But of course, just like one host on a container wasn't enough and we needed Kubernetes, we're now entering the realm of multi-cluster management. So one cluster is not enough. We have to be able to spread across different clusters, potentially in different environments. And this is where Matt and team have been doing a ton of thinking around what are the tools and processes in place that people can use to manage multiple clusters. So single pane of glass UI, policy syncing between clusters, CI/CD, service discovery, and even some demos that were shown off today of doing multi-cluster ingress using global load balancer and federating out to multiple clusters. But the big announcement that we talked about was really saying, okay, if we can do this on GKE, can we do it across environments? And this is where the ideas for GKE on-prem started to come into play. Customers said, we want those management capabilities of GKE and all of the service layers on top of that, and we want you to run it in our data center. And so this is what we've been working on for quite some time and trying to really flesh out the product and the vision of how we can take all of the bits and experience we've done with GKE and move that into an on-prem experience. And most of the announcements on day 1 and day 2 were focused on this whole family of products that we've called Cloud Services Platform that includes more than just Kubernetes. It includes all of the tools that sit on top of Kubernetes as well. And with that, Matt's going to go into a little bit more of a deep dive on what it means to do multi-cluster management.
Thanks, Wes. Yeah, so let's take a quick step back and discuss kind of what we're seeing as far as why people need multiple clusters in the real world. It is many, many reasons. So the first one we see a lot is I need to provide low latency services. So I've got customers in all over the globe, and I need to be able to serve them with low latency very quickly from wherever the closest cluster is to them. You can do this today with the Google Cloud Load Balancer. We have a tool that we built called kubemci, and we're working on some other tools as well to allow you to do this. In addition to that, people often say, you know what, I really want to have highly available services run across regions. So if I have an outage in, say, US Central, I want my traffic to fail over to the next closest region. This is something, again, that you can leverage Google's network to do. And it's something that kubemci and MCI, multi-cluster ingress in general, supports. In addition, we often see that customers have this data locality issue. So if I've got a customer that's traveling from an end user that's traveling from one location to another location, I need to serve them their traffic to the cluster that actually has their data. That's another important use case. The other one we see a lot, and this is more on the developer side, is I need to separate my teams, or maybe my tenants, or maybe I want to have different environments for dev, staging, and prod. And when you want to do that, you necessarily need multiple clusters. The other one we see is if you want to implement a multi-cloud, or we'll get into hybrid in a second, but a multi-cloud strategy, you also want to use multiple clusters. Nobody, as far as I know, really has a Kubernetes distribution that can span multiple providers and still be reliable. And finally, we often see that customers want to try a new version of Kubernetes safely, and they'll try to do it via canary clusters. And so they'll actually deploy the same workload on a new cluster, a new version of Kubernetes, and then they want to transition their workloads over from one cluster to another. So that's why people would want to use multiple clusters. But what about hybrid? So the cloud, we've determined, must collaborate with your on-prem, and that's exactly why we're building GKE on-prem. We see a lot where you've got legacy dependencies on premises. You might have an old database that really can't move to the cloud. You might have some services running there that really need to stay on-prem for a variety of regulatory reasons. And those need to stay there, and you need to be able to access them from the cloud. Another reason is local execution. So you might want to have a cluster running, or your services running in a warehouse on a factory floor, or in a branch of, say, a retail operation. And you might want to use CI/CD to push those things out and actually control the builds. The other one we see a lot is edge computing and IoT. So this is necessarily in a situation where you don't have great connectivity, and you might have loss of connectivity to the cloud, but you still want to be able to operate these clusters on-prem. Another one is global availability. You know, your cloud provider isn't going to be exactly in every region you want to be in, potentially. And so you can use GKE on-prem or just a hybrid in general to provide services in these locations. And then closely tied to that is the data locality. So there's a lot of restrictions on where you can house data, and you might want to have policy that you can enforce, and you can place it in a specific location. And finally, once you're on-prem, you can take advantage of a lot of the things that your cloud provider offers by reaching out from your on-prem to the cloud. And that necessarily means you need to invoke cloud services from on-prem. So as you can see, it's pretty clear that you really need to be, a lot of companies need to be thinking about being both on-prem and in the cloud. They need to be thinking about many clusters. So with that, I'll say, okay, multi-cluster and hybrid cloud is a reality. So what? It should be easy, right? It's not. There's a lot of challenges with this. So if I have kind of three things that I'll discuss here: workload, services, and environment. And the first one is the workloads. And there's a lot of challenges here. So just deployment and placement is a big challenge. You have technical and business requirements dictating where you're going to deploy your services. And your data locale requirements are going to dictate that as well. You probably want to have CI/CD integration in any kind of solution you come up with so that you have best practices around deployment. And then multi-cluster introspection is another issue. How do you ingest all your logs into one place? How do you monitor every service you've deployed, every workload you've deployed across many environments? Services as well is another big challenge. So I discussed this earlier when I just showed the multi-cluster use cases, but performance, low latency and geo-redundancy, that is something that people often think about when they're placing services. And then this is, again, where Istio and CSP in general, the cloud services platform, come in. We've got identity and security. So you can assign identities to your workloads, and you can set up access controls across environments. And finally, there's the environment. Compute is made a lot easier with Kubernetes. It provides an abstraction layer above your cloud provider, above your on-prem environment. But just having that isn't enough. I mean, Kubernetes has many different versions. If you're trying to be on the cutting edge of using the latest and greatest Kubernetes features, you might run into challenges with the API compatibility. A lot of people run into issues with OS images and cluster add-ons. And so it's not enough just to say, I've got Kubernetes and I'm done. And again, when we think about identity and security, there's also user identity and security and access controls that come into play here. How do I audit, say, a user's access to a cluster? How do I provide them the necessary access to that cluster and to that namespace or whatever it happens to be that they need to access in there? And these are all things that we're going to be discussing in the next the next section actually with GKE on-prem. So with that, I'll kick it back to you, Wes.
I'm going to check in with Nikhil. How are we doing?
I can register a cluster, but not synergy. I can register a cluster, but not bring up synergy cluster.
Okay, we'll check back in with you in a second. All right, so let's talk about GKE on-prem. If you want to go and get started with Kubernetes, I'm going to go to this side so you guys can see over there. If you want to get started with Kubernetes, one of the biggest challenges is actually getting the installation and configuration correct. If you go to kubernetes.io, it usually involves wading through over 40 distributions, 60 vendors that are offering Kubernetes solutions, and just choosing the right one can be a task in and of itself. Most of the time, people can get clusters up. I think the real challenge that I hear from a lot of cluster operators is how you actually manage this long term. This is really where a lot of the pain lies. Things like, how do you encrypt and back up at CD? How do you do security patches across your system? High availability is something that we've been working on for a very long time. It's a very complicated piece of setup where you have to have load balancers and redundancy separating etcd across multiple failure domains. And then finally, things like managing users and policies. That's also a very big one. When you start to not just think about the technical bits that make up a cluster, but how you assign quota and rate limit those out across your organization. Almost every customer that was using GKE that had some system on-prem came to us and they said, well, what do you recommend? And prior to this week, we kind of said, well, here's some great options out there, not by Google. And they said, but what we really want is GKE, but we want it on-prem. We want it in our own environment. And so that's when the team started going back and thinking, all right, well, maybe we can do this. Let's start thinking about what it is. This is the product for GKE on-prem. Our real goal is to try and figure out how we can bring turnkey, production-grade, easy installation, the best parts of the GKE experience to your environment. A lot of the stuff we've been hearing is like, if you can just solve installation and upgrade, I would be happy. We want to make sure that all of these things are tested and validated by Google and that we're constantly applying security patches. But we don't want to just stop at the Kubernetes layer. A lot of the stuff we're working on our cloud platform is expanding the capabilities of GKE to offer other higher level services. So things like Google Cloud Build, container registry, we have vulnerability scanning, we have a number of other features around like audit logging. We want to make these features that customers can use for GKE and Google Cloud Platform also available for our GKE on-prem product. And just as I introed, Cloud Services Platform is really sitting on top of this base layer that is GKE on-prem. We want to make sure that we can offer not just Kubernetes, but things like service abstractions, things like developer tools, and PaaS-like components that you can use to give to your developers. And that's where Knative Istio and some of the marketplace solutions come in. And Matt kind of alluded to this. We hear a lot of people say, well, the most important thing is really getting consistent. It's first off just the tool stack that they use to provision and upgrade Kubernetes, but it's also ensuring that you have conformant Kubernetes, that you have the same add-ons deployed in every cluster, you have the same configuration in every cluster. People really want high confidence that you can take a workload and make it portable. And the one real way to do that is ensure that your environments are consistent no matter where you're deploying. So for installation and configuration, the early focus for us has really been getting on a vSphere environment for our alpha, which is going to be available in the fall. The primitives are really trying to come up with what is that GK experience that we can offer. For the early versions that we have, we've been focusing on a nice CLI installation, supporting things like online and offline installation, private container registry support for people that are behind firewalls. And I think one of the most important pieces of this is the customers that we've been talking to want to move fast. They don't want to have year-long upgrade cycles. They see the pace of which we move with Kubernetes and GKE, and we want to help them move at that pace as well. So moving on the latest 3 versions of Kubernetes and keeping that rolling window updated is such a big core component of what we're trying to offer. And then we want to take some of the great features that we've been working on for GKE, things around high availability and like automatic repair of your nodes, to your on-prem environment. So, Nikhil, I'm going to check back in on the demo. How are we doing?
I can register a cluster.
Should we do that?
Yep.
All right. I'm going to kick it over to Nikhil, who's going to show you a quick demo.
All right, so we have GKE on-prem, which you can have your own cluster. But then the next step is, and really the powerful step is when you connect it to Google Cloud Console. So here, I'm showing you a Cloud Console, and I'm in the clusters view. And you can, before now, you can list your GKE clusters, and you see all the clusters there. You can go to the workloads UI and see your workloads on GKE cluster. But now what you'll see is we have this additional register external cluster. So what you can do using this is you can register your on-prem GKE cluster with Cloud Console. So let's try that out. I'm going to register external cluster. It gives me 2 options. I can use public internet connection to register my cluster, or I can use GKE Connect. Let's try GKE Connect. What it's going to do is it will ask me to install a Connect agent into my cluster, which will establish a tunnel from the cluster to Cloud Console, so that Cloud Console can then send requests to the cluster. So let's give my cluster a name. I want to give it on-prem cluster. And now I'll download the manifest, which I have to install into my cluster. So let's look at what the manifest looks like. The manifest has a service account that the agent will use. It has cluster role binding, and it has a deployment. This deployment is the agent that would establish the tunnel from the cluster to Cloud Console. So let's go ahead and apply it. You can see it created a service account, cluster role binding, and a deployment. And you can see this is waiting right now. And hopefully, fingers crossed, if the demo works, it should show us a green check mark. Awesome, it works. So now this shows that the agent was able to set up a connection from the cluster to Cloud Console. So let's try the next step. Now, Cloud Console needs some more information, which is basically the kubeconfig information for it to be able to send Kubernetes API requests to the cluster. So let's copy our kubeconfig. As you can see in this case, I'm using a minikube cluster. It could be a GKE on-prem cluster. It could be a GC cluster, a cluster you brought up yourself. It could be any Kubernetes cluster as long as it uses the Kubernetes API. So I'll go ahead and authenticate. I'll skip authentication for now. Just let's see registration works. Awesome. Now we see in the same clusters list view, you have your GKE cluster, which is the East Coast, and you also have your on-prem cluster. If I go to workloads, I continue to see workloads from my East Coast cluster, and ideally I should see workloads from this new cluster that I just registered. But since I haven't logged into it, I don't see it. So let's try to log into it. I'm sorry I have to type all of this, but so what I'm going to do is I'm going to use, let's see. I'm going to use the token of the service account that I just created for my agent. So I can use basic auth or token. In this case, I'm going to use token. And voila, it works. Now you can see workloads from your East Coast cluster and your on-prem cluster all in the workloads view. If I go back to my clusters list, you'll see now you can also see total cores, total memory. Earlier it was all blank. Now it can access all this information. If I click on my on-prem cluster, it shows me even more information. This is a v1.10 cluster that's running, what all storage information I have, what all nodes I have. In this case, I have just one cluster, one node, which is the Minikube API server. I can go dig deeper. So this now empowers me to use all the cloud console functionality that I was able to use with the GKE server now. I can now use it with my any other cluster as well, which is great.
Cool. Thanks, Nikhil. We had that demo working on the rack earlier. Technical snafu, but thank you for that. It shows not just that we can offer the GK experience on the box, but we can actually take any Kubernetes cluster and register with our cloud console now. So the question I often get is like, what does management mean for GK on-prem? A lot of the stuff that we want to offer is a Google managed experience, both through tooling, but also through a persistent connection with our cloud console where we can monitor and health check and keep things up to date. So part of what we're trying to go out with is both an option where Google manages your cluster, and also we have partner supports that can help deploy these in other environments. But even outside of that, we want to provide extra tooling above and beyond even what we have for some of the GKE stuff. So we want to make sure that we can get the right metrics out of the cluster, that we have automatic repair, and we even offer some node management features, such as node auto upgrade and node repair that we offer as part of our GKE on the cloud experience. Now, logging and monitoring is a little different in the sense that we know that a lot of people have to have a local logmon experience for doing debugging. We don't want to have to egress everything back to the cloud, but we do know some people want the best of both worlds. So what we're offering is a pre-built in cluster dashboard based off of a Prometheus, Grafana, and EFK stack. And after you do that, you can browse everything locally. You can have the metrics in your cluster and do some local debugging. You can then install Stackdriver agents and register with Google Cloud Console and have all of these metrics ingested into GCP. This is what we demoed at the keynote on day one, where we were actually showing metrics coming in and showing up on top of the service graph. Now, the real big power of this is we want people to use the same tools to manage both their GKE clusters in the cloud and on-prem. So we want Stackdriver to be that place where people go to set alerts and configure dashboards so that they can view both clusters in the same place. The best part is that Stackdriver supports Prometheus as a data store under the covers, so there's no extra instrumentation required. Identity is an area where we're working with a lot of customers and trying to figure out how we can meet their needs on-prem and also move them to the cloud. So we know that Active Directory is going to be a part of our solution. We want to integrate natively with people's local Active Directory trees. But for every feature that you need to use in Google Cloud Platform, we need to have a GCP identity. So we're exploring options, things like Google Cloud Directory Sync, things like provisioning a set of users for use in our Cloud Console and all of the GCP services. We'll have more details about some of this stuff a little bit later on. The other thing that we know customers are going to want is the ability to use their own cert authority in their on-prem cluster. So we're going to support the ability to bring your own public key infrastructure. Another part of CSP that we unveiled at Next is policy management. So this is a feature that allows you to create and define policies using a declarative configuration, check those into Git as a source of truth, and then federate and sync those across every cluster that you have, whether they're running in the cloud and on-prem. So this allows you to do things like set up how you want your users to access all of the clusters and then manage them centrally through Google Cloud Console and the policy management syncing tools. There's a bunch more depth that's going to be covered at a session tomorrow with Ray Colleen and John Murray, and that Thursday at 11:45 in Moscone West, if you want to hear more about this cool new feature. And then Nikhil was saying before, we really want Pantheon to be the place, or sorry, Cloud Console to be the place that people come in and manage all of their workloads and manage all of their clusters from a single pane of glass UI. GKE on-prem is special. This is a Google managed Kubernetes offering, and that's going to register seamlessly with Google Cloud Console. But there will also have the ability to take any Kubernetes cluster, whether they're running on Minikube locally or even in another cloud provider, and register it with our single pane of glass solution. Which is what we demoed, so we're going to skip that part of it right now. And Matt is going to tell you a little bit more about the GKE Connect agents.
There we go. All right, so we quickly showed you a demo of us connecting from Minikube back to GCP. And I want to just do a quick dive into what we actually did. So Nikhil mentioned we installed this connection agent onto the cluster. And what this is just a deployment that dials out from Google, from the cluster to Google, and creates a long-lived connection. Once we have that connection in place, we have the ability then to go back through the connection the other way and provide you this single pane of glass experience. So when an end user comes in and they talk to the Cloud Console, their request to view a workload on the cluster will route through that connection, back through the agent, and ultimately to the API server. The reason we did this is probably obvious, but if it's not, then I'll do a quick explanation here. So one is we don't really want people to have to expose their clusters to the public internet if they're running on-prem. And by having this agent reach out from their on-prem environment or your other cloud provider environment to Google Cloud, we can create an encrypted connection back to GCP, and it can traverse NATs and firewall rules, egress firewalls. We have proxy support, and we can create that long-lived connection and provide kind of a secure way to access your cluster remotely. The nice part about this also is because we are passing the end users, so you saw the page that Nikhil showed when we went to log into the cluster. We want every user to log in with their own credentials. And the reason we want to do that is we want your audit logs in your cluster to show a good audit trail of what's happening in that cluster. So when the first person, the administrator, registers the cluster, all that happens is it shows up for everybody. And everybody has to come in and log in separately. And if they use their end user credentials, like I said, we're going to have really good audit logs that end up in the cluster. So it makes auditing really, really good. So Wes mentioned also that this doesn't extend to just GKE on-prem or other GKE clusters. It really extends to bring your own Kubernetes clusters. And once we have the agent installed, we can do a lot of things. So I mentioned the single pane of glass, but we're looking at integrating with a lot of other services, including the marketplace and Stackdriver, and a bunch of other things to provide the GKE experience really for a lot of clusters that aren't even GKE. And with that, we'll wrap it up. There's a couple of things here I'll note. So one is that GKE on-prem, Google Kubernetes on-prem, is going to be available in alpha this fall. And also that we have a sign-up form. I think we're missing the link, so we'll put that up right before we wrap. But that's pretty much it. So we'll take questions off stage, and thank you very much for coming.